Okay, Module 17, adding and subtracting polynomials. Today we're going to go through the entire module. So it might seem like a lot, but you'll see that as we work through some of these problems, that it's stuff that you, first of all, might be familiar with. And if you're not familiar with it, it's fairly straightforward. Just a lot of keywords and definitions that I want to get through. But a lot of this you'll recognize. So let's get started. First, we're going to be talking about polynomials. So a polynomial is an expression containing a monomial, or the sum of monomials. Now, if you don't know what a monomial is just an algebraic expression that only has one term, like this. Okay, negative 6x would be a monomial. Okay. Now you might say, well, we have negative 6 and x, and you are correct, but it's still just one algebraic expression. We're not adding or subtracting anything to it. Okay, another example of a monomial would be 7x squared y to the third. That would also be a monomial. So if you have a sum of monomials, we call that a polynomial. This would be an example of a polynomial, and poly means many. And if you see this, we have many monomials in there. We have many terms in there separated by that plus sign, or plus or minus sign, and this would be called a polynomial. Okay, standard form is just a way of writing polynomials. It's a way of writing polynomials in terms of its degree, or of each monomial's degree. Okay, and you'll need to know how to find the degree of a monomial first in order to write a polynomial in standard form. And I'm gonna give you the definition of degree in just a moment, but go ahead and write down how to write in standard form, and then I'll show you what degree means, and we'll start writing some polynomials in standard form. All right, degree is just the greatest value among the sums of the exponents on the variables in each term. Now, that might seem like a lot of complicated jargon, but I'll walk you through it. So if we have a monomial, let's say it's x to the third, and I ask you for the degree of that monomial. That one's easy. I mean, you see that this variable is raised to the power of 3, so it would be a third degree monomial. The degree would be 3, okay? Where it gets a little tricky is if you get something like this, 7x squared y to the third power. Now, the degree for this one would be the sum of all of the exponents. Sum meaning addition. Because if you think of this, and let me do this in red, 7x squared y to the third is the same thing as saying 7x times x, and then y times y times y. So how many variables do we actually have? We have 5. So this would be a 5th degree monomial. So when you're looking for the degree of a monomial, all you would need to do is add the exponents. 2 plus 3 is 5. Now, if it's just a constant, like 7, doesn't have any variables, then you would say it would be a 0 degree monomial. So to write a polynomial in standard form, you must organize them in terms of their degree. So if you look at this polynomial, and we want to organize this in terms of its degree, you would take a look at the degree in each separate monomial. This first monomial has a degree of 1 because x is raised to the first power. There's one variable. Okay. This second monomial does not have any variables to it, so it's a constant actually. So it would be it would have a degree of 0. If we look at this third one, this has a degree of 2 because this x is raised to the second power. So if we wanted to organize this and write this in standard form, the third monomial would come first. It would be 2x squared. And then that would be followed by the monomial that had a degree of 1, which was 3x, and then followed by the constant. And that's all you would need to do to write a polynomial in standard form. All right, let's do one that has a bit more terms, and maybe let me add a constant to the end of this, some more variables. So if we're wanting to write this in standard form, you would need to find the degree of all the separate monomials. So if we look at this first monomial has a degree of, well, the x is raised to the second power, so it has a degree of 2. If we look at this second monomial, okay, the x is raised to the third power and the y is raised to the 5th power, all right? So the degree would be the sum of those. So this would have a degree of 8. If we look at this third monomial, we have a 2 and a 7. So the degree of this would be a 9. And then this last one is a constant, so it would have a degree of 0. Now, if we're wanting to write this in standard form, the one with the degree of 9 would have to go first. So this would be, let me do this in red, negative 7x squared y to the 7th, because remember this monomial was negative. Then we would follow that with the monomial that, oops, I don't know what I'm doing, the monomial that had a degree of 8. So that would be plus, let me do this in red, plus 4x to the 3rd y to the 5th. Then that would be followed by the monomial that had a degree of 2, which would be plus 5x squared, and then the constant would be last. That's all you would need to do to write a polynomial in standard form. All right. And when we start adding and subtracting polynomials, most of the time they're going to tell you to give all your final answers in standard form. Now let's talk about classifying polynomials by their terms, and this is where the vocabulary comes in. We have different names for different polynomials depending on how many terms they have. So if it only has one term, you've heard me say this word a few times already in this video lesson, so hopefully some of you already know. But if it only has one term, we call that a monomial. A monomial is a polynomial that only has one term. So an example of that would be just 7x squared y to the 3rd. That would be a monomial. If we have two terms, that would be a binomial. An example of that would be 7x squared y to the 3rd plus 5x to the 3rd power. Okay? If we have three terms, that would be a trinomial. An example of that would be 7x squared y to the 3rd power plus 5x to the 3rd power plus 4y. And if we have four or more, then we would just have, they call that a polynomial, which again, poly means more, or a lot, I'm sorry, a polynomial. And that would just be four or more, so 7x squared y to the 3rd plus 5x to the 3rd plus 4y, and then let's add a constant to that. Okay, and that would be how you would classify polynomials by their terms. So you're going to hear me say monomial, binomial, trinomial, and polynomial a lot during the next week and a half. So make sure you know what those terms mean. So very quickly, if we're asked to classify each polynomial by its degree, let's not worry about degree for now, but by the number of terms, here, this would just simply be a monomial. This would be a constant. Okay? Here, we have two terms, so this would be a binomial. And it would already be in standard form. Here, we have three terms. So this would be a trinomial. Now, is this in standard form? No, it's not. So let's go ahead and change this to standard form. If we look at this first monomial, it has a degree of 2. The second one has a degree of 4, and this third one has a degree of 5. So if we were to write this in standard form, this would be x to the 3rd y squared, then minus x to the 4th, and then plus x squared. That would be in standard form. Now, what kind of polynomial would this be? This would be a trinomial because we have three terms. Now let's get into the actual adding and subtracting of polynomials. So when we're adding and subtracting polynomials, all you need to do is basically, it's like combining like terms. You need to look for the monomials that have the same variables raised to the same exponents. So what do I mean by that? If we have 5x plus 5x squared, although both of these have an x, we would not actually be able to add them because one of them has an exponent of 2. And we've spoken about this in class before when we were combining like terms. Now, if this was 5x squared plus 5x squared, we would be able to combine them. And the way you would combine them is just like you would combine like terms. Okay, all you would do is just add the coefficients. So if we have 5x squared plus 5x squared, that would simply be 10x squared. But remember, they have to have the same variable or variables raised to the same power. So if this was 5xy plus 5x, you might say, well, we have an x here and an x here. We would not be able to add these two, though, because they do not have the same variables, okay? In order to add them, we would need an x and a y. So if we look at this top example here, it's if this confuses you, then just use the distributive property. This is the same thing as saying plus 1 times all that junk, okay? And we could also distribute a 1 here. So if we distribute a 1 here, that would just be 11x minus x squared plus 13. And if we distribute this plus 1 to all of these terms here, that would be plus 2x squared minus 23 minus 5x. Or you could just drop the parentheses, but it's really important that you remember this distributive property for when we get into the subtraction. And then here, all you would do is figure out which monomials have the same variable raised to the same exponent. So over here in blue, we have an 11x. Do you see any other terms that have an x, just an x, right over here? So we'd be able to combine those two terms, all right? Then in green, we have a negative x squared. Do you see any other terms that have, or any other monomials that have an x squared? Yes, right over here. And then in red, we have this constant 13. Do you see any other constants? Yes, right here, negative 23. So all we would do is add their coefficients. So with the blues, okay, 11x minus 5x, it would just be 11 minus 5, which is 6x. Okay, then with the green, it would just be, remember this is the same thing as saying negative 1x. So it would just be negative 1 plus 2, which is 1. So it would be plus 1x or just plus x squared. And then with the constants, it would just be 13 minus 23, which 13 minus 23 is negative 10. Now, this is not in standard form, so you would need to change it to standard form, and that would move the x squared up front. It would be x squared plus 6x minus 10. That would be your answer in standard form. And just for fun, what kind of polynomial would this be? This would be a trinomial. Now, what about when we are subtracting polynomials? Okay, so if we're subtracting polynomials, again, you would distribute, okay? So you could think of this as a negative 1, a positive 1. The positive one won't change that first binomial. It would still be 4x squared plus 5x. But this negative, it's actually going to change the sign of all the other terms in that second trinomial. So 7x times negative 1 is negative 7x. 3x squared times negative 1 is negative 3x squared. Positive 1 times negative 1 is negative 1. Then you would go ahead and combine like terms. We have a 4x squared here, and we have a negative 3x squared here. We have a 5x, positive 5x. We have a negative 7x. And then we just have that constant there, negative 1. Okay, combine like terms. 4x squared minus 3x squared would just be 1x squared or x squared. 5x minus 7x would just be minus 2x or negative 2x. And then we just have the negative 1. I'm going to have to do that in blue. I'm sorry, because I put a blue square around, so I meant to do that in blue. All right, it's for you students that like color coding your notes. And then we have minus 1. And this would already be in standard form, and this would be a trinomial. I want to do one more with you, another subtraction problem. So again, we would distribute that negative to each of the terms in that polynomial. The first one would remain the same. So this would still be q to the third r squared minus 6qr squared minus 21q. All right, and then we have negative 1 times negative qr squared would change that to a positive qr squared. Then we have negative 1 times a negative 6qr squared would change that to a positive 6qr squared. Then we have negative 1 times a negative 11q would change that to a positive 11q. And then negative 1 times that last negative monomial would change it to a positive 3q to the third r squared. And then we start combining like terms. Remember, they have to have the same variable or variables raised to the same power. So the first one in red here, we have to find any terms that have a q to the third r squared in them. And we do have a q to the third r squared over here. Now, over here and over here, we do have q and r, but they're not raised to the same exponent. Therefore, they're not the same as the ones in red. However, we are going to square those or put a rectangle around those in blue because they have qr squared, and we have one more qr squared right over here that we combine. All right, and then last in green, we have this negative 21q and this positive 11q that'll also be like terms. We're gonna go ahead and start combining them. So the reds first. We have q to the third r squared, which is the same thing as saying 1q to the third r squared plus 3q to the third r squared. So it's just 1 plus 3. 1 plus 3 is 4. 4q to the third r squared. Then in blue, we have negative 6qr squared plus, remember there's a 1 here, plus 1qr squared. That would give us a negative 5qr squared. But then we're adding another 6qr squared to it. So that's actually going to be just qr squared, 1qr squared. And if that was a little too fast for you, let me do that on the side here. We have negative 6qr squared plus 1qr squared plus 6qr squared. All right, so we're just adding the coefficients. So it's negative 6 plus 1 would be negative 5. And then negative 5 plus 6, that's how I got the positive 1qr squared. Okay, in case that was a little too fast for you, that's how I got the positive 1. And then last, the ones in green, we have negative 21 and positive 11. Negative 21 plus 11 is negative 10. And that would be negative 10q. Sorry, that was supposed to be in green. Negative 10q. And this is already in standard form, so we don't need to change anything. That's our answer. This would, again, be a trinomial. We're going to stop right here, but that's pretty much it. That's the entire Module 17. We'll go over this a little bit more tomorrow. And that's it. Have a great night.